In the traditional classroom as well as MOOC setting that all of us are familiar with, the same lessons in a fixed sequence are presented to all the students irrespective of their prior knowledge or learning speed. This adversely affects the quality of education as the individual learning requirements of all students are not usually met under the scheme. We live in an era of personalization where artificial intelligence can recommend to us the next best movie to watch or the next best product to buy. Then why not have AI recommend to a student the next best question to solve or the next best lecture to watch? This is the problem that I have studied as a part of my thesis work. Research has shown that personalizing education leads to an improvement in learning gains for the students while providing a more engaging learning experience. The first problem that we have studied is that of concept sequencing, where the aim is to generate a personalized sequence of topics in a curriculum that maximizes student learning in a learning by doing setting, where concepts are learned by doing activities. The objective here is to determine at each time step the concept that the student tends to learn faster and then provide a question or problem based on this concept. Now, this is determined based on the prerequisite relations between various concepts as well as the history of correctness of student responses to the other questions that were presented previously. We have proposed a technique that combines a reinforcement learning algorithm with a statistical change point detection technique that has outperformed prior state-of-the-art for concept sequencing. The second problem that we have studied is that of content sequencing. When multiple learning resources are available to master a concept, how to determine the right personalized order in which these resources are to be presented to a student in accordance with the individual learning characteristics. We have formulated this problem as a Markov decision process and proposed a reinforcement learning algorithm that determines an optimal sequence of learning resources to individual students. Another interesting problem that we have studied is that of tagging mathematical questions with labels of concepts that are required to solve them. Concept tagging is useful in determining the students' knowledge levels associated with various concepts based on the correctness of student response to a question. We have proposed a procedure that performs natural language processing on student explanations on solving a problem or a question and then determine the right concept tags associated with that question. So the hope is that our research would lead to the development of efficient, intelligent tutoring algorithms that provide personalized education, thereby making learning a more effective and enjoyable experience.